Aloha mai kako, aloha. This is Kumui. How are you guys? Thank you for the time and your attention in watching this video. This is going to be a tutorial and instructional video on how to complete the grade 8 CPT. So this is going to be coffee by the pound. Before we begin, I have a couple jokes for you. What coffee related, of course. What did one coffee say to the other coffee? The other one coffee said, "Where you been?" Okay. Second joke. What did the coffee say to the cream on Valentine's Day? It said, "It's hard for me to espresso myself, but I really love you a latte." All right, guys. Hope you enjoyed those and enjoyed not being in school to have to listen to those corny jokes in person. All right. So this is coffee by the pound. As you can see, we've got some places where you can buy coffee. We've got generic coffee. We've got Amazon. You can buy anything on Amazon. Honolulu Coffee. And I'm not sure what that logo that is. Have I been there? And of course, Starbucks. Everyone knows Starbucks. All right, so this is the grading criteria. I think your various kumu will have different ways of giving you credit for this assignment if you're still doing it. So I'm going to skip over this portion for now, but feel free to look over it yourself. If you have any questions, again, please direct them to your kumu. We're happy to help. Okay, the second page has 3 options to choose from. Okay, you've got 3 scenarios. And you're going to have to do all the parts, A through E for these scenarios. Okay, A through E for each scenario. But you only have to do 1. To really stretch yourself, though, what's interesting is if you do at least 2, you can even do 3. So what I'm going to do for you here is I'm going to go over 2 novel examples, 2 novel scenarios, and this isn't novel strains of virus, but 2 novel scenarios. And hopefully this should give you enough guidance on how to complete this activity for each customer, okay, whether you choose customer A, B, or C. So let me give you an example. For customer, let's call it D. For customer D, which we'll go through first, let's say it costs $81 for 3 pounds of Kona coffee. Let's say from Shopify or something, online markets. So $81 for 3 pounds of coffee. Now, the first question is, what is the cost per pound for this coffee? We need pounds. The ratio it's looking for, a unit rate, and the unit rate always has a denominator of 1. We're looking for dollars, okay, per pound. I was telling my 7th graders, we always want to think about this drawing, okay, and it's a smiley face. The P stands for price, the Q stands for quantity. So we always want price over the quantity. Okay, so we always want dollars per pound. So if we turn this into a unit rate, it would be $81 per 3 pounds. If we simplified this, I notice I have a calculator over here. This fraction bar we know is the operation of division. If you look at the division symbol on the left on the calculator, the division symbol indeed contains a fraction bar. So that's one thing always to keep in mind. So we can just do 81 divided by 3. This will yield $27 for 1 pound. Okay? And we could just, we can write that another way too. We could just write $27 per pound. Okay? And that's one way we can write our unit rate. Now this is of course reasonable because if it costs $27 per 1 pound, if we bought 3 pounds of that at the same rate, yeah, it should cost us 81 bucks. Okay? If we go over back to the left, if we have 27 per pound and I'm buying 3 pounds of that, that would be $81. So that is correct. The cost per pound for that coffee would be $27 per pound. Next, let's create a table relating pounds of coffee to cost. Now, in this hypothetical situation where it's $81 for 3 pounds, it costs $27 per pound. So on this left column, I want the independent variable. This is going to be my pounds. Okay, that's usually what I call the cause. And this will be the effect. Okay, so the cause is if I buy more coffee, the effect will be that I have to spend more money. Okay, so this is on the right column, it's going to be money. And this requires me to write at least 5 data points. So 1, 2, 3, 4, 5. There's more than enough cells for me here. If I buy, I want to start with 0. 0 is always a good place to start. If I bought 0 pounds of coffee D, I would spend $0. If I did 1 pound, it would be $27. If I bought 2 pounds, it would be 54. If I bought 3 pounds, it would be, 81. That's what was given earlier. How many data points is that? That's already 4. I'll just extend the table all the way. If I bought another pound of coffee, I would add another $27 to this, plus 27. So that would, single units digit would be at 8. This should be at 108. And if I bought 5 pounds, I'm going to add another 27. And that should be 135. Okay. 5 pounds of Kona coffee does indeed cost a lot. And you've done a lot of research. I think Kona coffee ranges from about, pure Kona coffee ranges from about $20 to $50 a pound one can expect to pay. So this is fairly reasonable. So there's the table. Okay. Now here's the thing. From the table, we should be able to translate that directly into a graph. Okay. So my table is up on the top. You can still see it. The graph, every graph, if you want to look back at the criteria, creating a graph, this is the bare minimum of what you need. Okay. You need a title. You need axes labeled with units. You need appropriate intervals used on axes, and coordinates are labeled. Okay. And we'll talk about that once I do my graph, give you a sample of this. Okay, so I'm going to say coffee price. It's not so clear. Coffee price versus weight. Okay, so I'm graphing coffee price versus weight. You can title this anything you want. How much money coffee costs, for example, or the price of coffee, you can say, or I don't know, you could even do a retail chart for coffee sales. Okay, so whatever title you want, this is just an example. So my table is up there. Over on this axis, I want coffee. And my unit is pounds. Okay, over on this axis, I want price. And my unit will be dollars. Okay, so I will carefully go in here. I might have to refer to my table a couple times, but maybe not. I'm going to go very carefully label this. This is 1. And what are we talking about? We're talking about pounds. Pounds of coffee. This is going to be 2, 3, 4, 5, 6. Why am I going there, up there? Because I need at least 5 points. The origin is not included. Okay? So I've got more than enough data points going that way. Now, up on this axis, there's a couple things we can do. We can label it in a very convenient manner in the vertical axis, going up by 27. Why 27? Because that was the cost per pound. But in order to be more general, I'm going to, let's say, go with, I'm going to go up by 20. Okay, so each unit is 20. This will be 40, 60, 80, 100, 120, 140, 160. Okay, because ultimately I'm going to put multiple graphs on this, and we'll see where we go from where we can go from there. So here's our first point. We've got 0 pounds of coffee will cost us $0. 1 pound of coffee is going to cost us $27. So that should be somewhere around there. Okay. I can label that point. Maybe I'll do it a little later. 2 pounds of coffee is going to cost me 54. Okay, so that should be around there. And 3 pounds of coffee, well, we know that it's going to cost $81, slightly above 80. That should be there. 4 pounds of coffee is going to cost me, let's just do this, 81 plus 27, 108. I could have gotten that, of course, from my table, though. Should be around here. 5 pounds of coffee at another 27 will be $135. So that should be right here. Okay. And 6 pounds of coffee at another 27, might as well. I'll be at 162. Okay, which should be right here. As you can see, even though my units going this way, the intervals are quite large, I can create a pretty accurate graph. And as you might be able to tell, the question is this a linear relationship? Well, if I extended this line through the points, it certainly does look linear. And this is an exact straight line I can do. As you can see, my graphs were fairly accurate, and it is indeed a linear relationship. Okay, so that's all you have to do for the graph. If you want to label your vertical and horizontal axes differently, or at least have the intervals different, you can feel free to do that. Now there's something I did not do. Let's go over this. Have I drawn a graph? Yes. And draw a graph, number of pounds of coffee and the total cost. Okay, so I have done that, but in these, in this criteria for meats, I need coordinates labeled. So you kind of do want to look at this. And of course, just watch the video. This is my example for you. So how can I label these coordinates? This first coordinate is 0, 0. This is 1, 27. Mind you, the x value stands for what again? The x value was, coffee in pounds. And the y value represents, price, okay, in dollars. So we've got 2, 54, 3, 81. Do I remember what these were? Let's go 4, if I added 27, that's 108, I believe that was. This was 5 pounds for 135. And lastly, this, I see it on the left still. Oh, I see some of my calculations up here. 4, 162. Okay. Oh, I'm sorry, not 4, 162, 6, 162. Okay, and you see how that aligns with all these points here. Okay, so that's the graph. Next, write the linear equation. Well, there's a couple ways we can write linear equation. For my class, at least, we were working on the relationship between table, graph, and equations. Okay, we want to identify variables, slope, and y-intercept. Let's just use x and y for the variables. X, not sure why that's not writing. X represents the pounds of coffee. Pounds of coffee. And y, in my case, will represent the cost or the price. Okay. So let's take a look. Looking back at the table, I would ask my class, did you notice any patterns? Well, the pattern should have been you're adding 27. You're adding 27. You're adding 27. Each and every time you increase the pounds by 1. Okay? You're adding 27 to the cost. That makes sense because each pound of coffee costs $27. So we had a way to write equations based on the table. We've got this with the x, and we also sometimes have a number out here. This, in my class, we called it the pattern number, at least when we were judging from table, pattern number. We also were on the verge of calling this slope. Okay. We also called, and the number by itself, we were calling this the starting number, at least with regard to a table. And we call this, we're on the verge of calling this the y-intercept in relation to the graph. Okay, so looking at our table, do we have a pattern number? All we need is a pattern, identify the pattern number and a starting number. So the pattern number we see right here. That's the pattern number. Okay. And the starting number we see right here. At 0 pounds, it costs $0. So that should make writing our equation relatively straightforward. Our linear equation for this situation in coffee will be y equals 27x plus 0. Okay, we don't need to write a 0 there if it's 0. Okay, because it doesn't affect matter. So if I clean this up a little, I would write y equals 27x. Now that makes sense because if I bought 0 pounds of coffee, if x were 0, x remember is my pounds of coffee. If x is 0, it would cost 0. My output would be y equals 0. If instead I plugged in x equals 1, if I bought 1 pound of coffee, x equals 1, it would be 27 times 1. Yes, it would cost me $27. And so on and so forth. If I bought 2 pounds of coffee, I would do 27 times 2, which would yield the cost. Okay, the product would represent the cost for however many pounds of coffee I buy. Okay, so in this situation, what is the meaning of the slope of the line? Well, the slope of the line is 27. Okay, it's 27 rise and 1 across. Up 27, 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 1 across. Now, in terms of up 27, what does going up mean? I'm going to leave some questions unanswered for you. Going up is this unit. Okay, so we're talking about $27 dollars. And whenever I go to over 1 unit to the right, I'm talking about one of these. Okay, one of these units. So the slope, which is this number here, it's also this number here. As we said, the slope and the pattern number are one and the same, depending if we're looking at the table or the graph. I need you to interpret the meaning of the slope here, and please write it in your own words what that slope represents. Okay. All right, so that's me going through one example. I'm also going to do a different scenario for you. Okay. So here's our second scenario situation. Let's say this is customer E. This is our novel situation here. Okay, for customer E, let us suppose I wrote down it's $28 for 2/3 of a pound. Let's say it costs $28 for 2/3 of a pound. Okay, so we're getting a little interesting here. There's a couple ways we can determine the cost per pound. And I will go to this shortcut. You always need P, that's the price, over the quantity. That's a shortcut, but I want to see if we can develop this answer a different way by actually starting with the table, which is part B. So I will make my own table here. And over on this side, I'm going to have pounds of coffee, and over on this side, I'm going to have cost. Okay. And I will need at least 5 data points. I will go all the way until, let's see. So for pounds, I will still start at 0 because if I bought 0 pounds of this particular type of coffee, it should cost $0. Okay. And instead of going 1, 2, 3, 4, I'm going to do something a little different here when I make my table. I'm going to go 2/3 of a pound. It will cost me. Why would I do 2/3? Because that I'm working with the given information. 2/3 of a pound of coffee will cost $28. Okay. If I bought then 4/3, if I doubled that order, that would cost me $56. Why? Because I'm buying twice 2 of these 2/3 pound bags. 2 of these 2/3 pound bags. Of course, it'll cost me twice as much, hence 56. But how many pounds would I get? Well, 2 of these 2/3 pound bags should be 4/3. 2/3 plus 2/3 is 4/3, okay? And we can think about that in terms of these circles. This is a 2/3, that's the representation of it. There's another 2/3. If I add this 2/3 to this 2/3, I should get 4/3. Yet if I added another 2/3, I would get 6/3. That will cost me another $28, so that should be 84. Okay, if I bought another 2/3, that would be 8/3. That should cost me another $28. So that should be 2, and I think I need to carry 84. 84 plus 28. Yep, 112. How many data points do I have? 1, 2, 3, 4, 5. Let's go one more. If I bought another 2/3 pound, that would be 10/3, and that would be another $28 I would need to spend, so that would be 140. Okay? So there's my table there, and I'm wondering, of course, I still haven't answered part A, which is, what is the cost? Hey, what's the cost per pound for this second type of coffee? Okay? So here, if I look at my data table, this is the point that's really going to help me. Why would that help me? Well, 6/3 of a pound, 6/3, 6/3 of a pound is 2 pounds. If 2 pounds, okay, 2 pounds would cost, that's 2, sorry, I'll write that again, 2 pounds of the same coffee would cost me $84. And if I knew that, that means each pound, if 2 pounds cost $84, if 2 pounds cost $84, then each pound would cost $42. Okay, and there's my answer. For this second type of coffee, my hypothetical example, it costs $42 per pound. And that's how I can write my unit rate. Now there's another way to find that, and it is simply doing this. Let me show you. We know it was $28, and this looks really weird, but you're just going to have to trust it. $28 for 2/3 of a pound. Why do we put dollars on top? Because look at this happy face guy again. Okay, we always want to make this happy face. We want price over the quantity. Price over quantity. Okay, so this calculator isn't as nice to work with, so I'm going to just use decimals. But what are we going to do here? We need 28 divided by 2/3 of a pound as a decimal is 0.66666. If your calculator takes fractions nicely, you would do that. So I've just entered 2/3, and I'm going to hit enter, and voila, that's our calculator rounding, but you see this is going to be $42 per pound. That is the more straightforward way if you understand how to get unit rates. This is going to be $42 per pound, which of course agrees with our earlier answer. Okay, it's $42 per pound. Now, we've found the unit price for the second scenario. We've drawn a table. Now my work is getting chaotic, but let's look at a cleaner graph. Okay, here we go. I may need to extend some of these points, but I know it's 42. I'm just going to prep my calculator here. 1 pound of this coffee, I'll use red. 1 pound will be $42. Should be somewhere around there. If I add another $42, it'll be 84. Should be right around here. If I add another $42, 3 pounds will be 126, somewhere around there. Add another $42. 4 pounds will be 168. Okay, I'll need some more values here. All right, we're spending a lot of money on coffee now. 4 pounds, 168, around there. And another 42, should be 210. 5 pounds will cost $210. That should be around there. Okay, and we'll go one more, plus another 48, 258. Oh, no. Sorry, 42. I'm adding 42. Sorry. So that was 210 plus 42. I'm just looking at my calculations back up here. 210 plus 42. 210 plus 42, that's 252. 6, 2. Oh, I will need more, obviously, more values here. And at 6 pounds, it will cost 252. Okay, so something like that. Now, the question becomes, is this a linear relationship? Well, let's take a look. If I draw my line out, see how accurate my graph is, even though, aha, there you go. So if I graphed accurately, calculated accurately, this should form a linear relationship. Why? Because for each and every pound, every additional pound costs the same amount of money. Okay, it's not like the jump from 4 pounds to 5 pounds is going to be more than the jump from 2 pounds to 3 pounds, for example. Okay, so there is our line for our second type of coffee. Okay, now we would encourage you to draw at least two graphs if you can. Meeting our expectations is just doing one, but if you want to go for the gusto, we're going to try to create a second line to compare costs and completes more than one customer scenario. Okay, so that's one way you can make this a little more challenging for yourself. Now, just studying the graph, it tells a lot of information. The red line, which is our second type of coffee, clearly costs, you should be able to tell, clearly costs a lot more per pound. For any given poundage, for example, let's take 4 pounds. There we hit the first type of coffee, but we still need to climb in terms of what's that unit. We still need to climb in terms of price to get to the second coffee. I haven't labeled the points yet, so let me do that. This was 0, 0, 142. Okay, this was 2. Do I have that? 42 plus 42, that's 84. This was going to be 3. And do I have that? Yep, I see it up on my calculator, 126. This was 4, comma, 168. This was 5, comma, 210. And lastly, this was 6, comma, 252. Okay, so those are my points. And what's the next step? The next step is to write the linear equation that represents this situation. Well, looking at this red line or my table, if I made, well, I think I'll use the graph now. If you can see, going through this, we go, for the red line, we go up 42 across 1, up another 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 42 across 1. And by going up 42, what I really mean is up $42 for 1 pound of coffee, okay? Because up is this unit, dollars, and going to the right is per pound of coffee. So my equation should be y equals 42x, where x is again the pounds of coffee and y is the cost. Yes, this makes sense. For every pound, I've got to, however many pounds I buy, I need to multiply by 42, which is the price per pound. So that would be my equation. There is no y, the y-intercept is 0, so there's no number, there's no constant by itself. And of course, I'll leave it to you in part E to interpret the slope, which is the number, the coefficient of the x, the number attached to the x when you're writing a linear equation. Okay, so guys, you can compare these two equations, and you can immediately tell what's happening there. Please fill out number E in your own words. What's the meaning of the slope in the lines we drew and the equation we wrote? Okay, so that hopefully guides you through the CPT, the Coffee by the Pound CPT. If you have any questions, please let us know. The expectations may be different for different kumu. My expectation for my class is please do all of these activities for at least one customer. Okay, I did this scenario, pretty straightforward. These two include fractions, but hey, that's why I walk through my second hypothetical customer E type of coffee for you. Okay, I hope that was helpful. If you have any questions, again, let me know. Hui ho, mahalo for your time and attention. Good luck, everyone.